recording. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, I've got a lot of questions this morning, requests, so let's get right to them. And let's see here. This is section 11.7. We're going to start with number 16. It says solve the equation, give the exact solution, enter your answers as a comma-separated list. If there is no solution, enter no solution. So we've got the log of the quantity 4 minus 3x over 4 times the quantity x plus 8 all equals 0. Okay. Now, first of all, what is implied but is not written? The fact that it's log base 10. If I take this logarithmic equation and change it into an exponential equation, I get the following. I get 10 to the 0 power equals the fraction 4 minus 3x over 4 times the quantity x plus 8. Any question about how I got that step? All right. 10 to the 0 power is 1. So I've got 1 equals 4 minus 3x. I'm going to go ahead and distribute that denominator, 4x plus 32. Well, now to clear the fraction, I'm going to multiply both sides by the LCD, which is 4x plus 32. So on the left side, I get 4x plus 32. And on the right side, I get 4 minus 3x. Again, any questions there? Solving for x, I'm going to put all the x's on the left, so I'll add 3x to both sides. 7x plus 32 equals 4. I'll subtract 32 from both sides. 7x equals negative 28. Divide by 7, and x equals negative 4. And there's your answer. Any questions about that? Okay. Next, we're going to look at number 17. It says solve the equation, give the exact solution, enter your answers as a comma-separated list. If there's no solution, enter no solution. It says e to the 5x equals 30. So I want to solve for the exponent, so I'm going to use logarithms. So this is going to be log base e of 30 equals 5x. But log base e is just natural log, so the natural log of 30 equals 5x. Okay, dividing both sides by 5, x equals the natural log of 30 over 5. And it said give the exact solution. I see that the person put in a decimal answer. Let me see here. If I take the natural log of 30 divided by 5, okay, so the thing that was wrong about the answer was that it just wanted the exact solution, not the decimal approximation. Otherwise, it was correct. Okay, let's take a look at number 18. Solve each equation, give the exact solution. So part A says log base 2 of x squared minus x equals 1. So we have a logarithmic equation. Let's change it into an exponential equation. We would get 2 to the 1 power equals x squared minus x. 2 to the 1 power is just 2. So 2 equals x squared minus x. We will subtract 2 from both sides. 0 equals x squared minus x minus 2. Well, now we have a quadratic or second degree equation. We can either solve it using factoring or the quadratic formula. I think this will factor fairly easily, so let's use that. Let's see, minus 2 and plus 1. So then we get x is 2 and x is -1. All right, now keep in mind that the base has to be greater than 0 and not equal to 1. That's fine. The quantity that we're taking the log of has to be positive. If x is 2, we'd have 2 squared, which is 4, minus 2 is 2. That's okay. If x is -1, x squared minus x would be -1 squared minus -1, which is 1 plus 1 is 2. Anyway, my point is both of these answers are correct. Both of them will work. Okay, any questions on that one? Here's number 18, part B. It says log base 30 of the quantity x squared minus x equals 1. Very similar. So now we've got 30 to the 1 power equals x squared minus x. 30 equals x squared minus x. Subtract 30 from both sides. 0 equals x squared minus x minus 30. Factor, we get, let's see, minus 6 and plus 5. So x is 6, x is -5. Again, if we put 6 or -5 in here, they both will work. Okay, also, let's see, we've got number 19 coming up as well. Number 19, it says solve each equation, give the exact solution. We have 5 to the 8x minus 1 power equals 625. Well, 625 is 25 times 25. But if 625 is 25 times 25, that would be 5 times 5 times 5 times 5, or 5 to the 4th power. So we have a base to a power equals the same base to a power. So the powers are equal. Solving for x, we'll add 1 to both sides. 8x equals 5, divide by 8, x equals 5/8. Any question on that problem? Okay, let's take a look. Let's see, that was 19 part A. Let's take a look at number 19 part B. And it says 5 to the 8x minus 1 equals 624. Well, 624 isn't a power of 5. So what am I going to do? Well, let's see. I'm going to have log base 5 of 624 equals 8x minus 1. But I've got to solve for x. Okay, tell you what, let's add 1 to both sides. So, and I'm going to put the 1 out in front. 1 plus log base 5 of 624 equals 8x. Then I'm going to divide everybody by 8. So I've got, let's see, I've got x equals 1 plus the log base 5 of 624, the whole thing over 8. Okay. Now, I'm going to use the change of base, and that's going to give me, let's see here, 1 plus the log of 624 over the log of 5, the whole thing divided by 8. Okay. And I believe that we could put that into our calculator. That would be the exact answer as it is right there. Okay, any questions about that? That one's kind of tricky. Okay, so now let's see, we're going to go to another person's questions. And this is here, and 7 or 11.7. Okay. Let's see, you can still see the whiteboard, right? You can see what I'm writing? No one's answering.
Yes.
Yes.
Okay, thank you. All right. It says fill in the blank. It says if 7 to the 2x equals 7 to the negative 5, then 2x equals, the answer would be negative 5. And you're just supposed to fill in the box there. Okay. And then let's see, number 17. Solve the equation, give the exact solution. And again, I see that the student gave a decimal approximation, so that might be why it's wrong. Let's see, e to the 4x equals 40. So log base e of 40 equals 4x. The natural log of 40 equals 4x. Divide both sides by 4. The natural log of 40 divided by 4, which is the right answer. Let's see, the natural log of 40 divided by 4. Yeah, that's what you, whoever it was that did this, you wrote a decimal approximation and they wanted the exact answer, so you should have stopped right there. Okay, number 19. Solve each equation, give the exact solution. This is part A. 4 to the 15x minus 1 equals 1024. And I believe that 1024 can be written as 4 to some power. So let's see, 1024 divided by 4. Oops, hang on. Let's see, 1024 divided by 4 is 256. So 1024 is 4 times 256. And that divided by 4 is 64, which is 4 to the 5th power. Okay, so 1024 is 4 to the 5th power. So 15x minus 1 equals 5. Add 1. 15x equals 6. Divide by 15, x equals 3/5. Wrong. X equals 2/5, because you take a 3 out. My bad. Sorry. So x is 2/5. Okay. Number 19, part B. 4 to the 15x minus 1. Number 19, part B. 4 to the 15x minus 1 equals 1023. So now I've got log base 4 of 1023 equals 15x minus 1. Okay, I'm going to add 1 to both sides. 1 plus log base 4 of 1023 equals 15x. I'm going to divide both sides by 15. So x equals 1 plus, I'm going to use the change of base. So log of 1023, hang on here. This is what I get when I've got lots to do. I get in a hurry, and that's not good. Log of 1023 over log of 4, and then that whole thing over 15. So that would be the exact answer. All right, let's see. We need number 23. Isotope of lead 201 Pb has a half-life of 8.4 hours. So the half-life is 8.4 hours. How many hours ago, so time is the unknown, was there 70% more of the substance? Okay, so A equals A sub 0, 2 to the negative T over H. And we need to figure out A and A sub 0. We're going backwards. How many hours ago was there 70% more of the substance? So now there's A, but the beginning amount was A plus 70% of A, which would be 1.7A. Okay? So A equals 1.7A times 2 to the negative T over 8.4. Divide both sides by a. 1 equals 1.7 times 2 to the negative t over 8.4. Divide both sides by 1.7, multiply by 10 over 10 to get rid of the decimal. 10/17 equals 2 to the negative t over 8.4 power. Okay, so now we're going to have log base 2 of 10/17 equals negative t to the 8.4 power. So I changed it to a logarithmic equation. Going to multiply both sides by negative 8.4. On the right side, the 8.4s and the negative goes away. So now I'm left with, I'm going to go to the next page. I'm going to have t equals negative 8.4 log base 2 of 10/17. Okay, so t equals negative 8.4 log of 10/17 over log of 2. And let's see, it says round your answer to 1 decimal place. So calculator, negative 8.4 log of 10 divided by 17, close it up, divided by log of 2, close it up, and I'm getting 6.43, so 6.4 hours. Okay, now we're going to go to the chapter review, number 11. Here. Okay, so this is the chapter review number 11. Says find the inverse. Oh, that was number 12. My bad. Yes, find the inverse of the function f of x equals 5 over x minus 1. So step number 1, replace the function notation with y. So y equals 5 over x minus 1. Step number 2, interchange all the x's and the y's. So x equals 5 divided by the quantity y minus 1. Step number 3, solve for y. I'm going to multiply both sides by y minus 1. So I get y minus 1 times x equals 5. I'm continuing to solve for y. I'm going to divide both sides by x. So y minus 1 equals 5 over x. I'll add 1 to both sides. So y equals 5 over x plus 1. And finally use f inverse function notation. So there's the inverse function. Okay. That takes us to number 14. It says use composition to show that f of x equals 5 minus 2x and f inverse of x equals negative the quantity x minus 5 over 2. Use composition of functions to show that they are inverses of one another. All right, so basically what we're doing is to show that if we compose them in both directions, we get x. Okay, so f composed with f inverse of x would be f of f inverse of x would be f of negative the quantity x minus 5 over 2, which would be 5 minus 2 times the quantity negative x minus 5 over 2. Okay, now let's see, that would be 5. And this negative out here is kind of like a negative 1 times the whole thing. So I'm going to get plus 2 times the quantity x minus 5 over 2. You okay with that step? But now distributing the 2, or in fact, just reducing it down, and we get 5 plus x minus x, and we get x. So we're halfway done. Now I've got to take f inverse composed with f of x. I'm going to erase this stuff. So if you're frantically copying it down, check the video later, because I needed more room. Here, f inverse composed with f of x is f inverse of f of x, which is f inverse of 5 minus 2x, which is negative 5 minus 2x minus 5 over 2, which is negative 2x over 2, which is negative x, which is x. And there you have it. Okay, so let's see here. We need number 38 on that same assignment. Number 38 says, solve the equation, express your answer to 4 decimal places. The natural log of x equals negative 7.5, but that's log base e of x equals negative 7.5. Changing it to an exponential equation, e to the negative 7.5 equals x, and I'm going to punch that into my calculator. E to the negative 7.5, and I'm getting 5.53084, rounding to, let's see here. Wait a second. Solve the equation expression in 4 decimal places. I see what I did wrong. I didn't use the correct grouping symbols. Oh, yes, I did. Yes, I did. Okay. This is 5.5308437. Oh, but it says e to the negative 4 power. So what does that mean? That means that to turn that into regular notation, this is like times 10 to the negative 4. So we've got to go backwards, what, 1, 2, 3, 4. So we've got 0.000553. And it said round to 4 places, which would be right there. That would round up, so you get 0.0006. Yeah, that's kind of a tricky problem because you've got to deal with scientific notation. Remember that? And then write it as a regular number. Okay. All right. Let's see here. Where did the mouse go? There it is. So 47 ED here and there. 7. Number 16. Okay. And the ones we're doing now, let's see, 16, 18. Yeah, we'll get there. We got time. We got time. These are very similar to ones we already did, just different numbers. That's okay. So this is number 16 from 11.7. And this one says log of the quantity 8 minus 3x over 4 times the quantity x plus 9 equals 0. So again, this is log base 10. So if we take this logarithmic equation and write it as an exponential equation, we get 10 to the 0 power equals the log of 8 minus 3x over, and I'm going to distribute 4x plus 36. But 10 to the 0 power is 1. So 1 equals the log of 8 minus 3x over 4x plus 36. Oh, what did I do wrong? I noticed I made a major mistake. When I took this equation and changed it, it's no longer a log, is it? Yeah, haste makes waste. So it would be 10 to the 0 equals this quantity. It's not the log of it. All right, now we're going to multiply both sides by 4x plus 36. So I get 4x plus 36 equals 8 minus 3x. I'm going to add 3x to both sides. 7x plus 36 equals 8. I'm going to subtract 36. 7x equals negative 28. Divide by 7x equals negative 4. Okay. Number 18. Pretty much, let's see, this is log base 30 of x squared minus x equals 1. Solve each equation, give the exact answer. If there's no solution, write no solution. So 30 to the 1 power equals x squared minus x. This time I remembered to get rid of the log, which means 30 equals x squared minus x. Subtract 30 from both sides. 0 equals x squared minus x minus 30. I think we actually had these exact same numbers. So x is 6 and x is negative 5. And if we plug them both in here, we get positive answers. So both values work. This was part A. Number 18, part B. Log base 20 of the quantity x squared minus x equals 1. So 20 to the 1 power equals x squared minus x. 20 equals x squared minus x. Subtract 20 from both sides. 0 equals, let's see, we get x minus 5 and x plus 4. So x is 5 and x is negative 4. I know I'm going at the speed of light here, but this was very similar to a problem we did earlier. Okay, this is 11.7, number 23. And it says an isotope of lead has a half-life of 8.4 hours. Okay, how many hours ago, so time is the unknown, was there 40% more of the substance? So this is again going into the past. So the final amount is the final amount, but the original amount is the final amount plus 40% of the final amount. So it's 100% plus 40%, or 1.4. Okay, so now we get A equals 1.4a times 2 to the negative t over 8.4 power. We're going to divide both sides by a. So 1 equals 1.4 times 2 to the negative t over 8.4 power. We'll divide both sides. Actually, you know what? I should have just divided both sides by 1.4a, and I could have done this all in one step. I didn't see that. I think last time I didn't see that either. I'm going to go back and do this more efficiently. So I have what? A equals 1.4a times 2 to the negative t over 8.4 power. I'm going to divide both sides by 1.4a. So that gives me 1 over 1.4. Multiply by 10 over 10. I get 10/14 or 5/7 equals what? 2 to the negative t over 8.4 power. Any questions how I got there?
No.
I'm going to take that and copy it on the next page. 5/7 equals 2 to the negative t over 8.4 power. So that means I've got log base 2 of 5/7 equals negative t over 8.4. Negative t over 8.4. So I'm going to multiply both sides by negative 8.4. So that I get t equals negative 8.4. I'm going to use the change of base, log of 5/7 over the log of 2. And they want us to approximate to 1 decimal place. So negative 8.4 log of 5 divided by 7, close it up, divided by the log of 2. And I get 4.077, rounding to 1 decimal place. The 7 rounds up, so 4.1 hours. And again, I know I'm going through that quickly, but it's just like the one we did earlier. I've got one more set of questions to get through here. We're going to make it. Famous last words. Okay, here. 11.7. Number 23. Another one of the lead problems. So this is 11.7, number 23. This one says, an isotope of lead 201 Pb has a half-life of 8.4 hours. How many hours ago was there 60% more of the substance? Okay. So the ending amount is the ending amount. The beginning amount is the ending amount plus 60%. So 1.6 A. So we've done, I think, 3 different versions of 23, all with different percentages. But in each case, you're going backwards. It's like there was more to start with. They give you the ending amount. You got to write the starting amount in terms of the ending amount. So A equals 1.6 A2 to the negative t over 8.4 power. I'm going to divide both sides by 1.6 A. So I get 1 over 1.6 equals 2 to the negative t over 8.4 power. I'm going to multiply by 10 over 10, giving me 10/16, giving me 5/8 equals 2 to the negative t over 8.4 power. I'm going to recopy that on the next page. 5/8 equals 2 to the negative t over 8.4 power. I'm going to now change this to a logarithmic equation. So log base 2 of 5/8 equals negative t over 8.4. We're going to multiply both sides by negative 8.4. So we're going to get what? T equals negative 8.4. I'm going to go ahead and apply the change of base. Log of 5/8 divided by log of 2. And let's see what we get. We get negative 8.4 log of 5 divided by 8, close it up, divided by log of 2, close it up. And I get 5.695. Rounding to the nearest tenth, the 9 would round up, and I get 5.7 hours. Okay, and I've got 2 more to go here. If I can find my mouse. Let's see. We now need a chapter review. Number 4. I think that's right. That's what they asked for. 4 number. Okay, well, they've got it right. That's why I'm surprised, but that's okay. So this is the chapter review, number 4. Maybe they figured it out. It says, let f of x equal x squared plus 1 and g of x equal 3x plus 2. And we're supposed to find g composed with f of x. So that would be equal to g of f of x, which would be g of x squared plus 1, right? Because this is f of x. So that would go in place of that. But that's equal to 3 times the quantity x squared plus 1 plus 2, which is 3x squared plus 3 plus 2, which is 3x squared plus 5. Okay. And now, let's see here, 44. So in the chapter review, number 44. A wooden statue found in Egypt has a carbon-14 content that is 3/4 of that found in living wood. If the half-life of carbon-14 is 5,700 years, how old, so time is the question, is the statue? All right, so A equals A naught 2 to the negative T over H power. The original amount, we don't know, but it is what it is. But the final amount is 3/4 of the original. So A would be 0.75 A naught. Okay, so unlike those last problems where they gave us the final amount and said that the original amount had a certain percent more, this one is saying the final amount is 3/4 of the original. So A is 0.75 of A sub 0, or A naught. Okay, so now I've got 0.75 A sub 0 equals A. Why do I call it A sub 0 sometimes and A naught sometimes? Because different people have different names for it, and I don't know which way to call it. So here we go, 5,700. Going to divide both sides by A sub 0. 0.75 equals 2 to the negative T over 5,700 power. Log base 2 of 0.75 equals negative T over 5,700. Multiply both sides by negative 5,700, and we get negative 5,700 log, I'm going to use change of base, 0.75 over log of 2. So T equals. Now, be careful, because some of these problems, they ask you for an exact answer, and some of they ask you, this one says round your answer to the nearest 100 years. I noticed people on forgetting to round appropriately. So make sure you read the directions. Negative 5,700 log of 0.75, close up, divided by log of 2, close it up. And I'm getting 2,365.713746. Rounding to the nearest 100 years, the 6 would round up, so it would be 2,400 years. Okay, I made it through all the questions that came in. We've still got 11 minutes left. Have any of you got any other questions you'd like me to look at before we go?
Yes.
What do you got?
On the chapter review, number 14.
Okay, hang on just a second.
And then number 44 on the chapter review, it marked my answer wrong, but I just followed the steps that you did and I did everything correctly.
Okay, hang on. So what was the first one?
Number 14.
On the chapter review?
Yes.
Okay, sorry, I was getting your stuff up here. So let's take a look at 14. Okay, can I share it?
Sure, go ahead.
Okay. Let's see. Oh, I see what you did right off the bat. Okay, so you see up here?
Yeah.
Okay, that negative sign, if you distribute it, you'd actually have, it'd be like taking -1 times the entire numerator. And so you'd have negative x plus 7. So right there, that should be a plus sign. Does that make sense?
Yeah.
Okay, I think that's probably the issue. Do you want me to go through it all, or are you okay with that?
Can we go through that one the whole way?
Sure. We'll do it. Okay, so let me write it down. F of x equals 7 minus 6x. F inverse of x equals negative the quantity x minus 7 over 6. And we're supposed to find it's the f composed with f inverse of x. That didn't work out. Okay, all right. So f composed with f inverse of x is f of f inverse of x, which is f of negative x minus 7 over 6. Okay, now let's take this. That's like negative 1 times, oops. That's like negative 1 times x minus 7 over 6, which is like negative x plus 7 over 6. Okay, do you see that?
Yes.
So instead of putting this in here, I'm going to put in the simplified version. Okay, so now that's going to be 7 minus 6 times negative x plus 7 over 6. All right, still with me?
Yes.
The 6's are going to reduce out, which is going to give me 7 minus the quantity negative x plus 7, which is 7 plus x minus 7, which is x. So again, it was that distributing this negative sign in the beginning that got you. Okay with that?
Yes.
Now, do you want me to do the second part?
If we have time, yeah.
Yeah, we've got time. Okay. So the second part is f inverse composed with f of x, which would be f inverse of f of x, okay, which is f inverse of, well, let's see, what was f of x? F of x was 7 minus 6x, okay? So we get that, okay? But let's see, f, I guess I need to write this down. F inverse of x was negative x minus 7 over 6, okay? So we're going to put this in there, and we're going to get negative 7 minus 6x minus 7 all over 6. The 7 and the minus 7 reduces, and we've got negative 6x over 6. The 6 is reduced, and we've got negative times negative x, which is x.
Okay.
Now, I'm going to go back and look at the screen that has the work. The thing you've got to do that might be different from what I did is that they're having you fill in the little pieces along the way. So basically what I would do with these is I would just do the problem and then go back and look at what you've done, and you can kind of see what goes in the box. Okay. The box problems always confuse students. I know it's because of, anyway, let's go back to here. And then it was number 40, what was it?
Number 44.
Okay, another Egypt problem. It says a wooden statue found in Egypt has a carbon-14 content that is 2/5 of that found in living wood. The half-life is 5,700 years. We're supposed to find the time. So let's see. The starting amount is a sub 0. The ending amount is 2/5, which would be 40%. or 0.4 of the starting amount. Does that make sense?
Yeah, that makes sense.
So using A equals A naught 2 to the negative T over H power, we get 0.4 A naught equals A naught 2 to the negative T over 5,700. We're going to divide both sides by A naught. 0.4 equals 2 to the negative T over 5,700, which is log base 2 of 0.4 equals negative T over 5,700. Multiply both sides by negative 5,700. We get T equals negative 5,700. I'm going to use the change of base right there and go to the calculator. See how I got there?
Yeah, I entered a wrong number, so
That'll do it, won't it? Every time. Bummer.
yeah.
And I got 7,534. It says round to the nearest 100 years, so 7,500 years. Anything else?
I have a question also.
Yes.
So we did my number, what was it? Number 19 on the 11.7 part B. And I entered it in the WebAssign and it keeps telling me it's wrong.
Okay, 11.7, number 19, part B. Okay. Let me, oh, I think I know what's wrong. Let's take a look. Okay, so you've got 5 to the 8x minus 1 equals 624, right?
Yes.
So log base 5 of 624 equals 8x minus 1. We're going to add 1 to both sides. 1 plus the log base 5 of 624 equals 8x. We're going to divide both sides by 8. Now, you wrote 1 plus the log of 624 over the log of 5 divided by 8. What's wrong is the whole thing's divided by 8.
Oh.
See it?
Yeah.
Yeah,
Okay.
your fraction bar just didn't extend quite far enough. An easy mistake to make. Yeah. So if you fix that and then see if that works.
Okay. Thank you, Mr. Mayo.
You're welcome. Well, folks, so here's the deal. Tomorrow is your chapter 11 test. Monday, I will be back at 11:30. We've just got basically an hour that we're going to spend reviewing for your final on Tuesday. So don't expect that I'm going to cover everything that you've ever done in Math 95 in an hour. What I would say is come Monday with questions that you have, and tell me ahead of time, and I'll do my best to get through as much of them as I can. All righty. So I will be back this afternoon at 1:15 if you have any other questions. Otherwise, hope you do well on your test, and I will see you on Monday.
Okay, thank you.
You're welcome. So we'll stop the